This is a part 7 recording continuation of inheritance of series. In the previous part 6 recording, I talked about the default constructor and destructor in derived class. Here our focus is on custom constructor for the derived class. Here I have a program which was created in previous recording. This animal class was actually created in part 5 recording of this inheritance of series, and this derived class with this default constructor and the destructor, it was created in the part 6 recording, in the previous recording. Here I will focus on the custom constructor for the derived class. So custom constructor will be needed for the derived class when if we want to create an object using this syntax instead of only simply um, uh, creating a default object with default value without passing the arguments values. I want to pass argument values, and I want this function, the function that actually creates the object, to set this passed value into its data members. So for this, uh, there are few things we need to be mindful of. We need to pass not only name of the base class, we also need to pass this information, number of bytes information. So for that, let me create a number of byte array int array equals to, let me have equals to, let me have 2 bytes in this year, current year, 5 bytes in the previous year, 4 bytes in the year before, and then 3 bytes in the year before that. So now I want to pass the name and number of bytes and the number of element in the byte 4. I want to create a constructor for the derived class which is able to receive this data and pass this data to the base class and copy this data into its resource attribute. So for that, here I am going to be writing this custom constructor. The syntax for the constructor is as usual, name of the class followed by the parenthesis. In the parenthesis we want to receive the name and we want to receive the information, the bytes information. It's going to be integer type, so int p and const int size. So now you want to forward this name to the base class. So the way of doing that is using this kind of syntax, right? You manually, if you don't do anything here, it will call the default constructor of the base class, which will not have the name value name data stored in it. It will call this function. So you need to manually call the custom constructor of the base class, and the syntax for that is a colon followed by name of the base class, and you pass the name into it, and after that you actually copy. You have a code to copy this two data in this last two parameters into the dynamic memory space to be pointed by this attribute. So first we want to set to the default state equals to null ptr and size equals to 0. Then you do validation if p is not equals to null ptr and size is positive. Then you do copy size into equals to, I think we should have p size here, let me have p size, because I don't want to have the same name for the parameter and same name for this attribute. So call it p size. Size equals to p size, and you allocate memory, uh, no, num of bytes equals to new int and size, and you in a loop int I equals to 0, I less than size I plus plus, you copy one by one equals to p, it should be bytes I guess. So let me change, make correction here, bytes. So this is the custom constructor we want to have. Let me check it. Default setting, validation, copy, shallow copying, and deep copying of the data. I'm copying into the deep, dynamic memory space. So yeah, I think this should be sufficient. Complete custom constructor, and we have the function to invoke. The statement to invoke custom constructor, and we also want to, and if I also want to display, in this case if I want to display, first let me see the output. I actually expect to display name and number of bytes information. First let me run this code, and I'll come back. There's going to be some problem here, not complete, but first let's see the output. Sorry, there's a problem. Oh, I think I actually needed to make that correction here. I actually changed this, but I didn't change here, so this should be bytes. Back to the terminal. Int pointer to int convert. Oh, I think there is still another problem there. Okay, so to the core, yeah, I need to put I here. Again, try. Now execution. So this, because of that, that cout statement actually only displayed the name. It didn't display the byte information, right? The reason is that we have not implemented a function that will display the byte. It did inherit the base class. Let me go here. So when I have this cout statement, it actually went ahead, because this is derived class. So derived class is actually a type of base class. Therefore if I have a base class insertion operator, and animal, that dog is also type of animal, so it the syntax, C++ syntax accepts the dog object here, and it actually executed this base class version, which only displays the name. It doesn't display the this byte information. So if I want to display this byte information, then I want to have something like this, the logic that actually displays the derived class data, something like this, but I would not display a name. I would do something like this. So display this number of byte information, maybe 4 OS let me just write this text, put this text, and then for int I equals to 0 and I less than size I plus plus os number of bytes I followed by maybe comma, then return os. So if we have this thing, and then also we want to have we have not come to the polymorphism, so we in this at this stage we also need to create this helper function for the derived class, otherwise it will go ahead and call the base class helper function. So this for the dog class, and let me call this dg. So this dog class, this statement will go ahead and invoke this operator, but the logic so far we have only displays the bytes, it doesn't display the name. So if I run this, it will only display the byte information. Let me show you. So only byte, there is no name. So if I want to display a name as well, then you need to manually call the base class this operator. So to call the base class operator, what we can do is maybe because we have this function inherited, so we can do something like this. Take the current object and cout or os, pass os to it. Now but this will actually represent the current object dog class, but we want this to refer to, this object, this pointer or this object to refer to the base class. So we want to cast it into the base class object. So this should invoke the base class version and display the name, and then after that this logic will actually display the byte information. So let us see whether it works or not. So the name and byte both displayed here, but actually we needed to, I wanted to put some thing here, maybe display in a different line. So after this I could do something like this, insert new line, so now the name and bytes are displayed in different lines. So and all this information may look noisier, but this was the information that was actually displayed in the previous recording. This actually this output actually are the result of this statement I have put in the destructor. For example, this cout statement, if I comment this out, and if I, let's say, comment this out, and also in the base class I have similar statements, and comment this out, then we can get rid of those what we see as a noise. So we have only name and bytes displayed at this point. So finally, this is the focus of this recording was this custom constructor, but just to display, I also did demonstrate how you can manually call the base class function from the derived class. Yeah, this is all I have to discuss on this topic. Thank you for watching. In the next recording, I will go ahead and discuss copy assignment operator, and after that copy constructor for the derived class.